Okay, hello everyone. So for today, we're going to talk about solving two-step equations. So the goals of this video tutorial is for you to learn how to apply inverse operations in solving two-step equations and to identify the solution of the given equation. So before I show you some examples on how to solve two-step equations, I want you to recall the order of operations. So the order of operations tells you what to do first when simplifying expressions involving brackets and multiple operations. So to easily recall the order of operations, we use the acronym BEDMAS. So BEDMAS stands for brackets, exponents, division, multiplication, addition, and subtraction. The order tells you that we should simplify the terms inside the brackets, followed by simplifying exponents, then doing division and multiplication, and the last is doing addition and subtraction. So BEDMAS helps you in simplifying an expression. Okay, but later on, we will connect order of operations when solving two-step equations. Okay, take note, class, that when we are solving an equation, we are undoing the expression. So when we are undoing the expression, we will apply the inverse operation and also the reverse order of operations. So a while ago, we talked about BEDMAS. Okay? So when we are undoing an expression, it means that we are doing the reverse order of operations. Okay? So it means that we're going to undo the terms containing addition and subtraction, followed by division and multiplication, then exponent, and then the last will be undoing the term inside the bracket. Okay? I will show you how to undo an expression. So suppose we want to undo 2x plus 8. Okay? So using the reverse order of operation, okay, we're going to undo the terms containing addition and subtraction. So if you will look at our expression 2x plus 8, we're going to undo plus 8 first. So to undo plus 8 means we will subtract this by 8. So 8 minus 8 is 0, so that will be cancelled. So what will remain? Only 2x. After undoing addition, we will undo operations involving division and multiplication. Since 2x means 2 multiplied by x, so we will undo multiplying by 2 by dividing it by 2. So 2 over 2 is 1, so we can cancel this. So that leaves you x. Okay? So x is already isolated, so it means that we are done undoing the expression. So remember, undoing the expression means isolating the unknown. Okay? So this concept of undoing the expression will be helpful when we are solving two-step equations. Let's have 5x plus 3 equals to 18 as our first example. Okay. So again, when we are undoing an expression, we want to isolate the unknown. So in this case, we want to isolate x. So we will undo 5x plus 3. But when we are undoing 5x plus 3, remember to always maintain the balance. So whatever we do on the left-hand side, we should still do it on the right-hand side. Okay? So again, doing the reverse BEDMAS. Okay? So to undo 5x plus 3, we will start with any expression or any terms containing addition or subtraction. So in this case, we have plus 3. So to undo it, we're going to subtract 3 on both sides. So that gives you 5x plus 3 minus 3 equals to 18 minus 3. So 3 minus 3 is 0, so we can cancel it out. So what is left is only 5x. And then 18 minus 3 is 15. So we're done undoing addition, so we will proceed with division or multiplication. So 5x means 5 multiplied by x. So to undo it, we divide both sides by 5. So 5 over 5 is actually 1, so we can cancel this. So what is left is only x, and then 15 divided by 5 is 3. X is already isolated, so x equals to 3 is the solution. Okay, so x equals to 3 is the solution. So if you want to know if your answer is correct, all you have to do is to substitute 3 to x to the original equation. Okay, so I hope that is clear. Again, what you need to do is to undo the expression. Okay, so to undo the expression, you need to follow the reverse order of operations. Okay, so let's have another example. Okay, so let's now proceed to our second example. So we have x minus 3 over 4 equals to 5. So remember in algebra, the fraction bar serves as a grouping symbol. Okay, so it implies a grouping symbol. So it means that in x minus 3 over 4, x minus 3 is one group and 4 is another group. Okay, so in the reverse BEDMAS, take note that undoing the expression inside the bracket is our last priority. Okay, so what we will do first is to undo the division. So to undo the division, we're going to multiply both sides of the equation by 4. So it will be 4 times x minus 3 over 4 equals to 5 times 4. So 4 over 4 will be cancelled. Okay, so x minus 3 will stay on the left hand side, and 5 times 4 is 20. So we're going to undo the group now, which is x minus 3. So to undo x minus 3, we will add 3 on both sides. So negative 3 plus 3 is 0, so we can cancel this. So what will remain is only x equals to 23. X is already isolated. Okay, the right hand side is already simplified, so x equals to 23 is the solution. So x equals to 23 is the solution. Okay, let's proceed to our next example. Okay, so for our third example, we have 6 times x plus 1 equals to negative 54. Okay, please take note that parenthesis is a grouping symbol. So we're going to undo x plus 1 as our last priority. Okay, the parenthesis is also an implied multiplication symbol. So our first goal is to undo multiplying by 6. So to undo it, we're going to divide both sides of the equation by 6. So 6 times x plus 1 divided by 6 equals to negative 54 divided by 6. So 6 over 6 is actually 1. So we can cancel this. So what will stay on the left hand side is only x plus 1. And negative 54 divided by 6 is negative 9. Okay. So we're going to undo the group x plus 1. So to undo it, we will subtract both sides of the equation by 1. Okay, so 1 minus 1 is 0, so cancel it out. So what is left behind is only x. Then negative 9 minus 1, they are both negative. So we're going to add them and then copy the common sign. So 9 plus 1 is 10. The common sign is negative. So x equals to negative 10 is the solution. So for you to determine if it is a solution, you just need to make sure that the unknown is already isolated. Okay? Let's proceed now to our fourth example. So here we have x over 5 minus 1 equals to 7. Take note that the minus 1 is separated to x over 5. So x over 5 is another term and minus 1 is another term. So what we will do first is to undo minus 1. Okay? So to undo minus 1, we will add 1 on both sides. So negative 1 plus 1 is 0. So x over 5 will remain on the left hand side. And 7 plus 1 is 8. So x over 5 means x divided by 5. So the inverse of dividing by 5 or to undo dividing by 5 is to multiply both sides of the equation by 5. So 5 over 5 is actually 1, so we can cancel it. So x will stay, and then 8 times 5 is 40. X is already isolated. The right hand side is already simplified. So x equals to 40 is the solution. Okay.